All right. We're going to be looking at symbols of elements. The first scientist to represent element with symbols was Berzelius in 1814. He suggested a systematic way of representing element with symbols. Now, as a chemist or a chemistry student, the language of chemistry is symbols. If you don't know symbols, then you are not ready to speak chemistry. So basically, for you to do in chemistry, you must understand these symbols. Now, how did they come out with symbols? In writing symbols of element, the first way was to pick the first letter of the element and write it in capital letter. Like for hydrogen, to pick the first alphabet, H. That is why I have the symbol of hydrogen as H. Oxygen, you pick the first alphabet, O. Nitrogen, you pick the first alphabet, N. Sulfur, you pick the first alphabet, S. Fluorine, you pick the first alphabet, F. Iodine, you pick the first alphabet, I. So this is how the elements with their symbol, this is how some of them come about. Picking the first symbol of the alphabet of the element, written in capital letter, I represent that element as a symbol. So anywhere you see H in chemistry, the language is what? Hydrogen. Anywhere you see O, it represents oxygen. Anywhere you see N, it represents nitrogen. Anywhere you see S, it represents sulfur. Anywhere you see F, it represents fluorine. Anywhere you see R, and like that. And then, in other cases, where the first letter has already been used, the system demands that you pick an alphabet and write it in small letters against the first letter written in capital letter. For example, we have helium. If you write helium as H, it's going to represent the same thing as hydrogen. So to avoid the confusion, you write helium and you pick this letter E and add to it. It becomes the symbol for helium, He. We have lithium, represented as Li. We have beryllium. Beryllium is represented as Be, because we have boron that is already represented with B. Now we have calcium represented with Ca, because we already have carbon that is represented with C. We have aluminium represented as Al. We also have chlorine written as Cl. So it's not in all cases that you have to pick the next alphabet. It can be any of the alphabet, as the case may be. It can be any of the alphabet. Like in chlorine now, C is written in capital letter, while the L is in small letter. The first letter is always in capital letter, while the second letters are always written in lowercase. The third set of representation with symbol is where the symbol is derived from the Latin name of the element. From the Latin name of the elements. So we have this element, we have the Latin name, and then the symbol. Element like sodium, the Latin name is derived, the symbol is derived from the Latin name natrium, written as Na. We have iron, the Latin name derived from, the symbol derived from the Latin name ferrum, written as Fe. We have copper, that the symbol is derived from the Latin name coprum, written as Cu. We have silver, derived from the Latin name argentum, written as Ag. I also have gold. The Latin name is aureum, as denoted as Au. So, in writing of symbols of elements, this is the way their symbols have been derived. Remember, I told you it was first suggested in 1814 by a scientist called Berzelius. And the first set of representation, the first alphabet of the name of the element is taken and written in capital letter. After that, for instance, we have hydrogen. This is the first letter in the name hydrogen. So you pick H and you write it in capital letter. After that, you move and pick where the capital letter, where the first letter has already been used. You pick any letter from the element was picked and then written in lowercase or a small letter attached to the capital letter, like in helium. Since hydrogen was already used, E was taken and attached to hydrogen and become He as symbol for helium. Then other elements, their symbols were derived from their Latin names. Like sodium, instead of writing S or SO, we have Na because the Latin name is natrium. Iron